Section 2.2, linear equations. To relate slope to perpendicularity and parallelism, to write or identify a linear equation in different forms, to compute the slope and y-intercept represented by a linear equation or graph. What's a linear function? A function whose graph is a straight line. You represent a linear function with a linear equation. Therefore, what's a linear equation? A linear equation in two variables is an equation that can be written in the form of ax plus by equals c. C is a constant, any real number. Y is the y value in the ordered pair, also represented by the y-axis. X, the x value represented in the ordered pair and the x-axis. A and B are also coefficients to x and y, and they are real numbers. Independent variable. If a function is defined by an equation using the variables x and y, where x represents the input values, then x is the independent variable. I usually identify the independent variable as something that you choose. We usually choose our x values. It's our choice. Therefore, if I choose an x value, I have dependent variables. If a function is defined by an equation using the variables x and y, where y represents an output value, then y is a dependent variable. I choose x, I substitute that value into the equation, then the y value comes out is dependent on the choice that I make as my input value for x. Now, what we want to do is to figure out how to graph a linear equation. First thing we want to do is copy the problem. Number 2, solve the equation for y. 3, create a table. In other words, we want to choose 3 input values, or our x values. 4, substitute your input values into the equation to determine your output values, which are your y values. Number 5, we want to graph the ordered pairs on a coordinate plane. Our first example, let's graph this linear equation, y equals 2/3 x minus 2. From the equation ax plus by equals c, my a would be the coefficient of my x, which is 2/3. My b would be the coefficient on my y, which is a positive 1. And my c is my constant, which is a negative 2. This is written a little bit differently, but it represents the same equation. So we copy the problem from the procedure before. That's step 1. Step 2, we solve for y. It's already done. Step 3, we create a table of my input values, which is my independent variable for my x. And I get, when I substitute in my output values, which is my dependent variable, y. Let's make some choices. For independent variable, I'm going to choose a 0. It's probably the easiest. Substituting in, 0 times 2/3 is 0. 0 minus 2 is a negative 2. Let's try 1. 1 times 2/3 is 2/3. 2/3 minus 2 is a negative 1 and 1/3. Try a negative 1. When I substitute in, a negative 1 times 2/3 is a negative 2/3 minus 2 is a negative 2 and 2/3. Usually, those are my easiest values. But notice I have a denominator for my coefficient of the x value. When that happens, a lot of times the easiest thing to substitute or choose for x are the multiples of that denominator. So that would be 3, negative 3, 6, negative 6, 9, negative 9, and so forth. So I'll show you a couple of them. When I substitute in a 3, 3 divided by 3 is 1, 1 times 2 is 2, 2 minus 2 is 0. And notice when I do use multiples of the denominator, the actual fraction dumps out. 6 divided by 3 is 2, 2 times 2 is 4, 4 minus 2 is 2. All input values are acceptable as long as I do the correct math procedures to get the correct output values. Now the only thing I need to do is to graph these ordered pairs. So 0, negative 2, 1, negative 1/3, negative 1, negative 2/3, 3, 0, and 6, 2. Now what I want to do is connect those points with a straight line. This graph represents that linear function. Next, let's graph 3x minus 2y equals a negative 4. Here, 3 would be my a, representing an ax plus by equals c. Negative 2 would represent the b, and c would be negative 4. Our procedure to graph is copy the problem. Step 1. Step 2 would be to solve this equation for y. So I'm going to subtract 3x on both sides. That gives me a negative 2y equals a negative 3x minus 4. Divide both sides by a negative 2. That gives me y equal to, the negative 2 will go under both of these, and it can simplify in each if possible. Negative divided by a negative is a positive 3 over 2x. Negative divided by a negative is a positive. 4 divided by 2 is 2. Next, I create a table of my input and output values, my x and y values. Let's choose. I'm going to choose 0. 0 times 3 over 2 is 0. 0 plus 2 is 2. I can choose 1. 1 times 3 over 2 is 3 over 2. 3 over 2 plus 2 is going to give me 3.5. I can choose 2. 2 divided by 2 is 1. 1 times 3 is 3. 3 plus 2 is 5. Again, notice when I choose the multiples of the denominator, the fraction will dump out by division, and then we can just work with the whole numbers. We also could use negative values. Let's substitute our 3 values onto the graph. I'm going to get 0, 2, 1, 3.5, 2, 5. And then we connect with a straight line. Next, we want to graph the equation, negative 2x minus 5. Here in the equation, ax plus by equals c. A would be a negative 2. C is a negative 5. But notice there is no y term. That's because b in that term would have been 0, and 0 times y is 0. Therefore, it would eliminate in the equation, and I'm left with just a negative 2x minus 5. So step 1 is to copy the problem. Step 2 is solve for y, but there is no y. So what do I do? Well, then I need to solve for the variable that is there. So I'm going to solve for x. I'm going to divide by a negative 2 on both sides. That gives me x equals a negative divided by a negative is a positive 5 over 2. Now, I create a table of x, y values. Here, x is not, in a sense, a independent variable. I can't have a choice because I know what x equals. No matter what I have, x has to equal 5 over 2. And notice I have to put that in 3 times to generate an equation that can put a straight line on this graph. So I have 5 over 2, 5 over 2, 5 over 2. What can y be? Y can be any number. So therefore, I just choose 0, 1, and 2. I could choose 0, negative 1, negative 2. But I'm going to choose numbers that are small, that are easy to graph. So when I graph them, this is going to be 5 over 2, which is 2.5. So 2.5, 0, 2.5, 1, and 2.5, 2. And when I connect with a straight line, that's going to give me a vertical line. And that should make sense since the only term that I have here is an x value. Therefore, the only time I have just x values is when the line crosses only the x-axis. The only way to cross just the x-axis is if I don't have a y value. This line will never intersect the y-axis. Therefore, I only have an x value. So if I have an x, I get a vertical line. What would happen if I just have a y? Y would then be a horizontal line. Let's take a look at this example to verify. Here, in my ax plus by equals c, c is a negative 4. A would be 0. 0 times x is 0, therefore the x term eliminates, and I'm left with 3y. So we copy the problem and then solve for y, divide by 3. Y equals a negative 4/3. Now I create a table. Now y has to be this value of a negative 4/3. Then I can make my x anything, 0, 1, 2. Then I graph. Now we already know this should be a horizontal line. Let's just verify. 0, a negative 4/3 is a negative 1 1/3. 1, negative 1 1/3. 2, negative 1 1/3. And when I connect with a straight line, that verifies that when I have an equation without an x term, just the y term, I get a horizontal line. Our next slide, slope. The slope of a non-vertical line is the ratio of the vertical change to a corresponding horizontal change. The slope of a vertical line is undefined. The slope on a graph is the pitch of the line on that graph. For the vertical change, that is the change of the y values, and the horizontal change is the change of the x values. So our formula for slope is rise over run, and it is known as y sub 2 minus y sub 1, x sub 2 minus x sub 1. Its symbol for slope is also the lowercase m. Y sub 2, y sub 1 over x sub 2 minus x sub 1. And how we generate the x sub 2, y sub 2 is through an ordered pair. We're given ordered pairs. For example, 1, negative 3, 4, negative 2. We know that this is x and y, x and y. Now all we do is label one of the ordered pairs sub 1 and sub 2. Here I'm going to label this x sub 2, y sub 2. And if that's the case, then the second ordered pair would be x sub 1, y sub 1. It doesn't matter which one you let be sub 1 or sub 2. Here's the procedure to determine slope given 2 points or 2 points from a graph. Number 1, we want to copy the points or determine 2 points from the graph of a line. 2, label the x values x sub 1, x sub 2, and the y values y sub 1, y sub 2. 3, substitute into the slope formula and simplify. Here we have 2 ordered pairs. Let's label them x and y, x and y. I'm going to label this x sub 2, y sub 2, then the other ordered pair would be 1 and 1. Now we just substitute into the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. For y sub 2, we have 4 minus a negative 3. Watch your signs. For x sub 2, we have a negative 2 minus 5. Now we just simplify. 4 plus 3 is 7 over a negative 2 minus 5 is a negative 7. Therefore, our slope is a negative 1. If I would graph these points, I have a negative 2, 4, and 5, negative 3. And if I generate a straight line, I can see when I count down 1 over 1. That is my slope. The rise of 1 and the fall of 1 and a horizontal change of 1. And when my line drops from left to right on my coordinate plane, it is a negative slope. If it would climb from left to right, it would be a positive slope. Another example, we have a negative 2, negative 5, negative 2, 7. Let's label x sub 2, y sub 2, x sub 1, y sub 1. Again, you can change the y sub 1 and y sub 2 and the x sub 2, x sub 1. It doesn't matter as long as you start and finish the same way. Let's substitute into our slope formula. M equals y sub 2 is a negative 5 minus y sub 1 is 7 over x sub 2 is a negative 2 minus x sub 1 is a negative 2. When I simplify, that's going to give me a negative 12 over a negative 2 plus 2 is 0. Therefore, this slope is undefined. And I know from our definition, we know that would be a vertical line, but let's graph this to verify. A negative 2, negative 5, negative 2, 1, 2, 3, 4, 5, and a negative 2, 7. 1, 2, 3, 4, 5, 6, 7. And there I have my vertical line, and that's represented with a slope that is undefined. Our next example, ordered pairs of 3, negative 8 and negative 6, negative 8. X, Y, X, Y. Let's label this one 1 and 1 this time, and the other one would be 2 and 2. Substituting into our slope formula, we're going to have y sub 2, which is a negative 8, minus y sub 1, which is a negative 8. Again, watch the signs. X sub 2, which is a negative 6, minus x sub 1, which is 3. Simplifying, that's going to give me a negative 8 plus 8, which is 0, over a negative 9. And when I simplify that, that gives me a slope of 0. Let's graph this to see what a slope of 0 line looks like. So here I have 3, 1, 2, 3, negative 8, 1, 2, 3, 4, 5, 6, 7, 8. And we have negative 6, negative 8. 6, negative 6, and down 8. And that generates a horizontal line. A vertical line has a slope that's undefined. A horizontal line has a slope that is 0. On the next example, they want us to determine the slope, but here we are given a graph rather than the ordered pairs. But to determine the ordered pairs, we want to use ordered pairs that generate whole numbers. So here we have 0, 0. And also, we're going to have 3, 4. If I substitute that into my slope formula, letting 3, 4 be x sub 2, y sub 2, and 0, 0 be x sub 1, y sub 1. That way we'll have 4 minus 0 over 3 minus 0, giving us 4/3 as my slope. I also could actually count from one point to the next point in the style of city block. So in other words, straight up, 1, 2, 3, 4. That's my vertical change. And counting 3 to the right is my horizontal change. By my definition, I know the rise, or the vertical change, which is 4, over the run, or the horizontal change, is 3. I can do the same from this point to 0, 0, counting down 4, and to the left 3. So it doesn't matter what point I start at, as long as I count the units and put it in rise over run. I also am aware that my graph increases from left to right. Therefore, I know my slope is positive. Our next graph is a horizontal line. I know its slope is 0. I can verify that with 2 points. Here I'm going to use 0, 2, and also 1, 2, 3, 3, 2. And when I substitute, letting that be my x sub 2, y sub 2, 2 minus 2 over 3 minus 0. That's going to give me 2 minus 2 is 0 over 3. And we know 0 divided by 3 is 0, giving me a slope of 0. Our next example, again, we're given a graph of a line. Here we still want to find 2 ordered pairs. So here I'm going to pick an ordered pair, which is going to give me whole numbers, and I have a negative 3, 3, And another ordered pair is going to give me positive 1, 1. And I can substitute into my formula, letting 1, 1 be x sub 2, y sub 2. So 1 minus 3 over 1 minus a negative 3. And when I simplify, that's a negative 2 over 4, which is a negative 1/2. I could also count from one point to the next point, going down 1, 2, and over 1, 2, 3, 4. Gives me 2, 4. Vertical change of 2 over horizontal change of 4, which gives me a slope of 1/2. But realizing that my line is decreasing from left to right makes this a negative slope. I also could have counted from this point going up 2 and to the left 4. That would still generate a slope of a negative 1/2. Our next example gives me a vertical line. We know our slope is undefined. And I can verify that with points. Here I'm given 1, 2, 3, 4, a negative 4, 0, and also a negative 4, negative 2. And when I substitute, letting this be x sub 2, y sub 2, a negative 2 minus 0 over a negative 4 minus a negative 4 gives me a negative 2 over 0, which we know is undefined.